This is the SR-71. It was created by the company of Lockheed. The SR-71 was the second aircraft in the Skunk Works project headed by Kelly Johnson. The SR-71 is best known for being a major advance in reconnaissance aircraft, flying at Mach 3, that's faster than the speed of a bullet from an M16 rifle, and at an altitude of 85,000 feet, it was and is the fastest manned aircraft.
The SR-71 is 32.7 meters long and weighs 135,000 to over 140,000 pounds. The skin was made of 85% titanium and 15% carbon composites. Quite ironically, the titanium for this Cold War plane was purchased from the Soviet Union. The reason for this composition is mainly the air friction. It would be looking at about 1000 degrees Fahrenheit or 538 degrees Celsius. Contrary to common belief, titanium is actually quite sensitive and would break if mishandled, so titanium tools also had to be manufactured. The SR-71 costed $33 million to produce. It was very expensive.
The SR-71 first flew on the 22nd of December, 1964. The entire plane was designed to limit radar signature from engine positioning to specially designed paint. The extent of the aircraft's warning system for anti-aircraft weapons was a red light on the control panel. That would be the last the pilot would see of the weapon, as surface-to-air missiles would miss widely and end up being miles off target. While 12 of the 32 planes were lost, none of them were shot down. This plane was discontinued in 1990 due to political reasons and is currently resting in the Smithsonian.
The fuel of the SR-71 is JP-7. JP-7 was specially designed to not ignite until necessary. Another interesting feature to JP-7 is that it would be pumped throughout the plane to cool it. Because the emissors would be operating at such a high temperature, JP-7 was developed to have a chemical ignition. The fuel uses triphenylborane for the ignition. Ben Rich, the successor of Kelly Johnson, often tells how a lit match can be dropped in the JP-7 and the match would simply be put out. JP-7 and other aviation fuels are composed mainly of hydrocarbon compounds, like cycloparaffins, paraffins, olefins, and aromatics. Cycloparaffins and paraffins are the biggest part of the fuel. Cycloparaffins are added to increase the density and decrease the freezing point. The paraffins, burn cleaner, are added to increase the energy of the fuel. A formula based on estimated molecular weight and average composition is C12H25, although it differs based on a variety of factors such as refinery conditions, crude oil sources, seasons of production, and changes from batch as it ages. JP-7 is categorized as a kerosene like many jet propellants. One issue of the SR-71 is that it would leak fuel during the takeoff. This was mainly due to the fact that the fuel tank would contract at a high temperature and expand after landing. This meant that the SR-71 needed to be refueled shortly after taking off using an aerial tanker such as the KC-135. One of the many effects of the SR-71 was the fact that it was used to defuse a situation between Libya and Egypt that might have otherwise resulted in a nuclear war.
The SR-71 takes off from sea level at a height of 85,000 feet, with a pressure of 0.0011 kPa and a temperature of 538 degrees Celsius. How much oxygen is required to burn JP-7 on a flight path from New York City to Paris? The flight path is 5,570 kilometers, and it took the SR-71 1 hour, 54 minutes, and 54.6 seconds for the flight. The density of JP-7 is 793 grams per liter, and the SR-71 burns roughly 18,927 liters of fuel an hour.